Now, in this video, I want to show you some examples where we will involve a thing called back substitution. Okay, so we said to solve for this integral, first we will need to write this integral in terms of u, right? We want to write everything into u. And then that function is supposed to be very simple, and then we use a power rule. We can find the antiderivative of that function, and then next we bring the x back. We can find the answer to this integral, right? So for this function, I let u be 2x minus 1. If u is 2x minus 1, then du over dx gonna be 2. So dx gonna be what? Du over 2. Okay. If I substitute u for 2x minus 1 and I substitute du over 2 for dx, now you will see the integral becomes x times the square root of u times du over 2. Okay, now we still have an x in the function which we cannot get rid of. Now, in the previous video, we said if this happens, probably we need to go back and think about other thing and to be u, right? But if you look at this problem, seems that this is the best way to choose u, right? This quantity 2x minus 1 is under the square root. Of course, we cannot let x be u. If we let x be u, we actually just rewrite everything in using a different variable, but we didn't change the function. So if this happens, we will use this technique, which is called back substitution. So since we know that u is 2x minus 1, from this equation, if we solve it for x, then we can know how to write x in terms of u. Now this equation tells us how to write u in terms of x, right? Now we do the reverse thing. We can know how to write x in terms of u. Since u equals 2x minus 1, if we solve this for x, so u plus 1 equals 2x, right? And then we divide it by 2. Therefore, x equals u plus 1 over 2. So we find that x equals u plus 1 over 2. Okay, which is 1 over 2 times u plus 1. Now we substitute 1 over 2 times u plus 1 for x. Now the integral becomes 1 over 2 times u plus 1 times the square root of u times du over 2. 1 over 2 times 1 over 2, this gave us 1 over 4. Okay, it seems that this function is as difficult as this one. How can we make this function to be easier? Well, if you try to simplify this function, you will see that actually this function is not that hard. Because let me first rewrite the square root of u into u to the power of 1 over 2. Now, if I distribute this term into u plus 1, I will get u times u to the power of 1/2 plus 1 times u to the power of 1/2 du. And u times u to the power of 1/2. we can do this by using the property of exponent, because this is a u to the 1 and this is 1/2, so it's a 1 plus 1/2, which is u to the power of 3/2. Okay. Now, what we have is a sum of two exponential functions. And if I split them, I will get integral of u to the power of 3/2 du plus a second integral u to the power of 1/2 du. For each integral, we can solve it by using the power rule. Now the first one is u to the power of 3/2 plus 1 over 3/2 plus 1. For the second integral, the answer is u to the power of 1/2 plus 1 over 1/2 plus 1. 3/2 plus 1, that is 5/2. So 5/2, 5/2, and this is 3/2. So we have 2/5 times u to the power of 5/2 plus 2/3 times u to the power of 3/2. Okay. Now at the end, don't forget to bring the x back. Since u is a 2x minus 1, so the answer is 1/4 times 2. 2/5 times 2x minus 1 to the power of 5/2 plus 2/3 times 2x minus 1 to the power of 3/2 plus c. And once we distribute 1/4, so 1/4 times 2/5, that is 1/10. And this is 1/6. Okay. So the answer is this.